In this video, we'll go back and look at one of the other questions that we've looked at before, this time asking whether the collision was elastic or inelastic. Kinetic energy is conserved in an elastic collision. It is not conserved in an inelastic collision. Remember, momentum is always conserved. Now, in any real-world collision, there will be some kinetic energy lost, even if it's a mostly elastic collision. So for our purposes, we're going to say 90+%, or sometimes even 80+% is enough for us to say that it was an elastic collision. If it's less than that, then the collision was inelastic. So looking at the two-dimensional car crash problem that we did earlier, one car was coming in toward the north, the other was going to the west. There was a collision, and we found that they go off stuck together at 7.4 meters per second at an angle 30.4 degrees north of west. So these are all the same knowns as before, except now I've added what we found before also to the knowns. First thing we want to know, is the collision elastic or inelastic? That's really easy to answer on this problem, because if the two things stick together, it's inelastic. So we know immediately it's an inelastic collision. The kinetic energy should not be conserved. So now we're going to find out what percentage of kinetic energy was converted to thermal. So we need K initial and we need K final. K initial, this would be 1/2 mv squared, right? Except we have two different things moving at different speeds. So m1 v1 initial squared, and then the second thing, 1/2 m2 v2 initial squared. K final, also 1/2 mv squared. This time they're stuck together. So we can do the total mass times just V final. So this is 1/2 1500 kg times 8 meters per second squared plus 1/2 times 1700 kg times 12 meters per second squared. This is 1/2 1500, so 3200 kg times 7.4 meters per second squared. So what we're looking for is K final over K initial. That will be the ratio of the two. And we're looking for it as a percentage, so we'll multiply it by 100%. One 400 joules is K initial from this. And then K final gives us 87,600 joules. So this comes up to 51.4%. So 51.4% of the initial kinetic energy went into final kinetic energy. We're looking for how much was converted to thermal. So if we consider an energy bar graph, at the beginning it's all kinetic. At the end, the only things there are is kinetic and thermal. So whatever this kinetic was here, initial kinetic minus the final kinetic, has to give us E thermal. So that means E thermal should be 48.6%. So there's our answer.